today we're going to look at the practicals that we're doing. There's three practicals in one. The first one that you may have done, I don't know how many people have done it, was the perfect egg practical. I haven't done it yet, so this is going to be the first time that I'm doing it right now, and we will see if it works or not. So I'm going to sometimes ask you questions, what you think we should do, and then we're going to do it together. Okay? Alright. So the first thing that we actually looked at was to find the amount or the mass of the water to cook an egg perfectly. And so can somebody tell me the equation that we need for that? The equation for calculating enthalpy.
Heat change equals mass multiplied by specific heat capacity multiplied by temperature change.
Okay, that's the equation that we basically are going to look at all the time. Now in terms of egg, we need the mass, that's in grams, right? Heat capacity, does anybody remember what the heat capacity was of egg?
3.18,
3.18, so 3.18, and then we need to look at the temperature change, okay? With the temperature change for the egg, we have the egg now at room temperature. So where are we going to start off with? What temperature?
Room temperature.
What's that?
23 degrees.
So usually that's what you want. 25 degrees Celsius. At what temperature would be the perfect egg? Do you remember that temperature? 64 degrees. Okay. So that's hopefully where we're going to get up to. And we need to know, this is the question now, we need to know the mass, okay, that we've used, okay? Okay. And so we're going to have, well, this is now an egg that I just cooked regularly. And it's actually really difficult to cook an egg right perfectly. Because this one I cooked, and it is not that great. It's not soft. It's really hard inside, so it's not really a perfect cooked egg. But maybe we're going to be able to do that right now. Okay, so first of all, from you, I need now. What do you think? I mean, in a perfect world, how much gram would we need of the water? Perfect world.
31 grams.
31 grams. However, what is that assuming?
All heat is absorbed.
That's right. All heat from the water is absorbed by the egg. Obviously, that's not happening because we have lots of heat going to the surroundings. And so, what now I want you to do is give me a prediction of how much grams of water we would actually need, and then we try it out.
more than 100.
More than 100. Okay. Anybody giving you a more specific suggestion than that?
420.
420. Okay.
Is that too much?
Well, I don't know. I need a bigger bowl now. Okay. Okay, 420. I'm now measuring this out. Okay, 423. That's what we got here. So I want to have it boiling, so I'm going to put it into the kettle. I'll boil it up, and then I'll put it into this bowl, and I'll put the egg. Well, I'll put the egg already in here, and see what happens. What's the time frame that we want it to be in the water? What do you suggest? What's the time?
An hour.
An hour. Okay, we don't have an hour, so maybe let's say 20 minutes.
Okay.
Okay. So we're going to have that water in for 20 minutes and see if the egg is going to be okay or not. Okay. Maybe we're going to have another bowl, and the second go. And can somebody give me another suggestion of how much water? Maybe less than 420.
1 cup, which is 237 grams.
237.
Okay, yeah.
237, okay. Okay, 237 exact. Look at that. Okay. Once that is finished, we're going to put that in here. So we've got 420 gram here, and we got 237 gram in here. Can you see that? Okay,
Yes.
420. It's going in. Can somebody tell me, stop the time and tell me when it's, let's say 15 minutes. So we're not wasting too much time. 15 minutes. Can somebody put the clock on? Did anybody do put the clock on? Phoebe?
Okay, I'll do it.
Okay. Okay. Anam, 437. Okay, it's going in now.
15 minutes, right?
15. That's right. Okay. All right. You'll see actually the egg. You can't really see it right now, but maybe I'm going to make it a little picture. So the egg is actually not quite submerged for the 237, but it is for the 420. So just something that you should note. Okay. We need to leave that be for the moment. We're going to go to another practical. So this one is what we've already sort of discussed. This is what we're going to discuss this lesson, and this is a little sneak peek for the next practical that we're going to do. Okay? All right. Today's lesson is all about the Maillard reaction. We're going to introduce this reaction. It is one of the key reactions in cooking, and where chemistry and cooking really merges together and links together. Understanding the Maillard reaction actually will make you a better cook, because you can understand how everything works together. The Maillard reaction basically is telling us what temperature we need to create these amazing flavors. When a raw food has one flavor, but it has a completely different flavor when we cook it. And that happens when we have this Maillard reaction. Bakery, for example. There's a little bit of browning on top when the bread is ready or whatever. That's the Maillard reaction, and it has a completely different taste. With the steak, the brown on the outside, that's again the Maillard reaction, and it has these totally different flavors. And depending on which temperature we're using, we're creating all these new different aroma substances. And so today we're going to look and just cook the steak regularly. Later on, you're going to watch a video that I've prepared for you where there is another way of cooking a steak, which is actually more accurate. It is entirely difficult to cook a steak because seconds are actually really important, because there's different doneness. So if you want to have a medium rare steak, you want to have the internal temperature at 63 degrees. But the Maillard reaction doesn't actually happen at 63 degrees. So on the outside, we want a completely different temperature. On the outside, we want to have something between 140 to 180 degrees. So you're going to have different temperature. You want outside one temperature, inside another temperature, and everything perfect. So timing is so important. If you're cooking a different method, like a sous vide cooking method, then time is less of an issue. Look at that video yourself. For a medium rare steak, you want to have each side cooked at around for 3.5 minutes. And so can another person give me the 3.5 minute mark? Who can be the timekeeper for that?
I'll do it. It's 3.5, right?
3.5 minutes, okay? All right.
When do I start?
Not yet. When the steak is in the pan, that's when you're starting, okay?
Okay.
So the oil is hot. I'm going to put it in now. Time starts now. Did you put the timer on?
Yes.
Okay, good. Okay, in 3.5 minutes we need to quickly turn it over. And my frying pan actually tells me, which is electric cooker, that it is at 200 degrees Celsius actually. So that means that we don't need 200 degrees Celsius, but again, a lot of heat is going to go to surroundings. So the pan is actually hotter than we need on the outside of the steak, and we certainly don't need 200 degrees inside of the steak. That's why timing is so important. And obviously now if I change the temperature of the pan, then my timing will also maybe change. So that's why it's very tricky to cook a steak, because we need the exact temperatures. So today what you're going to do, you're going to actually do two calculations. One calculation will be to identify the enthalpy used if you think perfect conditions, 63 degrees on the inside and 63 and 170 degrees maybe on the outside. You want to determine what's the enthalpy that you've used. The steak that we have right now, that we're cooking right now, I think it's around 150 grams. Also, we're going to look at the reaction first and the second step, and you're going to look at the actual chemical equation to then work out bond enthalpy, and we're going to look at bond enthalpy, and the video explains a little bit about how to do that.
15 seconds. Okay, click it.
Okay. Actually, maybe I can send the picture even in the chat. Okay, that's what it looks like right now inside. So you have that rounding on the outside, and inside we're hoping that it's 64 degrees, so that at 63 degrees. So you have a medium rare sort of look, pink inside still. Okay. You also need to do for this side 3.5 minutes, right?
Yeah, I did
okay.
that, yeah.
And make sure that you tell me when the timing is over with the egg as well. Remember.
Yeah.
Okay. So with bond enthalpies, it's a little bit different. When we talk about bond enthalpies, we have to look at the reaction, because we need to know what the chemicals were before, the reactants and the product. And then we're looking at which bonds are broken and which bonds are formed. So when we break bonds, we need energy to break the bonds. So it's really an endothermic process. But when we make bonds, we release energy. And so that's an exothermic process. And depending on how much energy we use to break the bonds, and then how much energy we gain to make the bonds, the total will either be a negative for exothermic or positive for endothermic. Okay? But we need to look at the whole sum. So the coefficients of all the moles of the reactions is really important. And so you need to look at which bonds are broken in the molecule and times that by the coefficient of that molecule. Okay? In this case, with the Maillard reaction, the coefficients are all 1. Because it's an organic reaction, and often the coefficients are just 1. Because there's only a slight change. So in this case, you don't need to worry so much about coefficient, but when you later on do some exercises, please be aware that you need to times the amount of average bond enthalpy by the coefficient of that molecule. Alice, is it 3.5 minutes now?
Yeah, done.
Yeah, it is? Okay.
Yeah.
So the big reveal is obviously now if it is the right doneness inside.